when we start the problem. Through working through all this, I know that this phase, or actually these four phasors, we've got 3 current phasors and the voltage phasor. These 4 phasors are 1.056 ahead of the voltage of the power supply. Radians. And then since there's a right angle here between VC and VR, we can calculate this angle. And let's go ahead and do that while we're here. I was going to erase stuff first and then do it, but what is this angle?
90 minus pi sub 2.
90 minus what?
Oh, I'm sorry, it would be 90 degrees. It would be 2 pi divided by 4 minus 1.056.
No, wait, it's a right triangle. It's a right triangle.
Right, and 1/4 of 2 pi would be the 90 degrees.
Is it just 45?
Wait, are we using degrees
It's not
or
45.
radians?
Is it 30?
I'm sorry.
It's probably going to be closer to 30, but we can do better than that.
So we're not using radians.
Well, I would prefer radians.
Was my approach?
Your approach was right. The fact that you did 2 pi divided by 4 as opposed to just jumping straight to pi over 2
Yeah,
was,
that was more than my brain could handle, I guess.
Okay.
Sorry.
if, as a reminder, 90 degrees is pi over 2 radians.
I will try to.
Or 2 pi over 4 if you like that. So
That's actually easier for me, I'm sorry.
Okay, hey, whatever works. So this angle right here is going to be pi over 2 minus the 1.056.
Okay.
Oh my goodness.
Why is this so hard?
Or you could do the arctan of R over XC. We've already done this work. Anyone gone through and actually figured out what it is? 0.57 something or 6 something?
Point 515.
Point
515.
515?
That's what I got.
All right, so that's right. I was in the middle of erasing.
Have you ever taught somewhere that have the whiteboards that like slide up or like rotate? Like when I was an undergrad, there were a lot of very fancy long whiteboards that had like rotating pieces that like shove into parts of the wall.
Not as marker boards. I've done it with chalkboards where they had the multiple layers. Because I'm that old.
They had chalkboards when I was at Al.
And
That was like a couple of years ago. That's what we used. We never used whiteboard.
Yeah, I mean, from an environmental point of view, chalkboards are far better because there's a whole lot of plastic that just gets tossed.
Right.
All right, so the last thing that we need to do, the last piece of information is we need to somehow figure out, we have this relationship here, but I don't know what I is, and I can't figure out I unless I know one other piece of information. Typically, I need something in order to find that. So, have I stuck the probes into the outlet yet for this group?
No.
Okay, so let's do that.
Okay.
All right, so what we're doing here is I set this on volts because I want to measure voltage. If I put it in right now, it's probably going to give me some small value. Typically it does. Some small value, and it's not going to change a whole lot. So let's go ahead and do that. And I've got 29.4 millivolts, 28.8, 29.1. It's jumping all over the place. Why is it jumping all over the place?
Always does. It's a multimeter.
Yeah.
AC.
On fuse? I don't know.
It's AC.
And what does that mean?
You have to switch to DC.
Yeah, it's oscillating, the voltage is oscillating back and forth like this, and I have this thing set on direct current, it's the default, So it's taking, it assumes we have a constant value, so it takes a measurement, then it does another one and another one. So when you're doing measurements with this, hit select so that it's measuring AC. It is still oscillating back and forth, but now I'm going to stick these into the outlet. And that is not right. I'm sticking it into a different outlet.
Is that something you would
What if
recommend?
that's?
Yeah,
Again,
should we do this on our own time?
Right.
I thought this was like the exact opposite of what they
I know.
told everybody to do ever.
It's not, it's not.
Maybe that's the.
There we go. That was right. Apparently this is
Here, it's still fine.
less of an issue. Can you already read that?
I'll do it.
Yeah,
I
I
can.
7 to, no, not a
It's-
7.
it's a
That's
one.
12,
It's a
or no, we have one.
12.45.
Yeah, I see the 4 or 5.
Yeah, 12.45.
It's 124.5. That's what
Oh.
it is here.
How
Yeah,
do you-
this is not a 12-volt battery here or power supply.
Yeah, of course not.
All right, so the standard voltage that I would expect is somewhere around 120 volts in the US. It varies depending on where you are in the world, but 124.5, it's a little bit of oscillation, a little bit of handshaking. All right, so what I measured there was the voltage, 124.5 volts. Now, if the voltage is oscillating back and forth, what is this value?
Our slope. Our slope.
But the slope is constantly changing too, so it's not the slope, but even if it were, the slope at what point?
I was gonna say, it seems like it'd be the average between the minimum and maximum values.
All right, so what is the average between the minimum and maximum values?
The axis?
Which is,
0.
yeah,
Ah.
the average value is 0, so, but if it told me 0, that really doesn't tell me a whole lot.
Oh, so it's the
So that's
absolute
like the
value
max. Yeah.
of the max or min.
It's a what?
The absolute value of the maximum or minimum.
They decided not to go that route. They could have, and occasionally I see speculation that, or I see comments in various things of, they could have done it this way, but they decided to do it another way. It seems like they always decide to do it another way.
Anna, you're right, but you're actually not right.
Right. Well, he's fishing for us to come up with something we don't know anything about. He must expect us to come up.
This is the RMS value.
Yeah, no idea what that is. Obviously.
And I don't even know how you figured that out, to be honest.
The root mean square.
Okay.
Now this tells you how they find the average. Because we have a cosine function here, we have some amplitude, epsilon sub 0, cosine of omega t plus phi. So the first thing they do is they square this. Then they find the average of this value, and then they take the square root of it. So basically what they're doing to our function is going in that order and figuring out what value you end up with. So they square it, they take the average, and then they take the square root. It requires calculus to actually solve this, so I'm going to jump to the chase. This is equal to the maximum value divided by the square root of 2. RMS value is always the maximum value divided by square root of 2 if we're talking about something that oscillates like a trig function, like a sine or cosine, which is what we're working with. Therefore, my maximum value of voltage in this case, epsilon sub naught, is 124.5 in this part case right here, times the square root of 2. Which is something which someone will share with me.
$176.1. Oh God.
Well, this is the maximum, so
It's volts times square root of 2, so it's gotta still be in volts. The square root of 2 doesn't have units.
Yeah, it's volts.
Oh, right, cause that's epsilon in this case is.
Yeah.
So that is what we have right here. So what we need to do over here is I need to tell you some piece of information. So I typically give a RMS value. So VRMS, let's make 100 volts. Therefore, my maximum value, oh, yes, Kaner.
Why don't you divide it by 2?
Yeah, I was gonna ask, cause you multiplied by the square root of 2 instead of dividing it.
Because the maximum value divided by square root of 2 is equal to the RMS value. So to solve for V max, I have to multiply both sides by square root of 2.
Oh, yeah.
Right,
okay.
V max is this epsilon stuff now.
Yeah.
I think that was the gap.
Yeah, this is the maximum.
Okay, thank you.
Yeah, I was confused with that too.
There it is. You gotta spoon feed it.
Yeah. Before we're done, I'll have a couple more symbols there. All right. So if my RMS value is 100 volts, what is my maximum value?
176.1.
No, that's if my RMS value is 124.5
Oh,
volts. This was real life over here.
right,
This is a word problem over here.
141.4 volts.
And by the way, sticking things into an outlet, metal things into an outlet, generally not a good idea.
Good to know.
But if you know how to use a meter, it's okay to do it.
So I should buy one and go do that at home.
Thanks, physics class.
All right. So what we have here at this point, given our problem over there, my equation for my the voltage from the power supply is equal to 141.4 volts times the cosine of something that was erased, is 377 radians per second times time plus 0. You don't have to write the plus 0, I'm just emphasizing that it's there. I know that my maximum value from the power supply, this 141.4, is equal to the current times the impedance. So 141.4 equals I times 101.6 ohms, I guess that's volts. So what is my maximum current?
1.39 volts. Current, sorry, amperes.
1.39 amperes, okay? And now I know what I is. I can figure out what my maximum voltage of my resistance is, because that's I times R. So that's 1.39 amperes times, I think it was 50 ohms.
Got 69.5, but I also didn't round off the 1.39.
Okay. Units?
This is the maximum volts, right? So just volts.
Okay. And then I can figure out the maximum voltage for the capacitor, because that is I times X sub C, which is 1.39 amperes times 88.4. Yep, 88.4 ohms.
I got 123.03. Oh, that's still volts.
I hope so.
I got 122.876.
I didn't round to 1.39, so that might be why.
Oh, I see, got it.
Alright, so I now know the maximum voltage, so my voltage across the resistor is 69.5 volts times the cosine of 377 radians per second times time. My voltage leads, so plus 1.056.
Is that our 5?
That's the phi sub 2. That is this angle, that is the angle between my V sub r and epsilon.
Oh, yeah, okay.
V sub c, well, my maximum value is 123.03 volts times the cosine of 377 radians per second times time. What's the phase shift? Or what's the phase difference between the voltage coming out of the power supply and the voltage across the capacitor?
Is it pi? Is it pi?
Not
No,
pi.
I'm sorry, it'd be pi over 2.
All right, if you're stopping there, no. That's the difference between VC and VR. I was asking between VC and VPS.
VR.
VPS overlap with VR.
VR is here, VPS is here.
Oh, so it's pi
VC.
over 2 minus phi sub 2 would be that angle.
Yeah, so minus 0.515. Or you could take this and just subtract pi over 2. And you see the look of joy and you're thinking, man, this is great, can we do another one after this? And yeah, we can.
Yeah, I'd actually like to.
Yeah, I would like some more factors in the end.
It's like maybe 2 or 3.
We have one last equation to come up with. Actually, we're gonna come up with 3 equations all at once because all my currents are in sync. All the currents are the same. So my current from the power supply is the same as the current from across the capacitor, the same as the current across the resistor. Because it's a series circuit, the current's always the same.
Just a quick question, how
Yep.
did we find the 1.056 again?
That was okay, that was the angle between these two. From this right here, just taking a look at that right triangle.
Mm-hmm,
We had the arctan, or the tangent of phi 2 is VC over VR, opposite over adjacent.
uh-huh,
That's equal to IXC over IR. I's cancel out. And then once we found XC and R, we did our arctan.
R10, okay,
That is when we sat and struggled to find out what that angle was.
gotcha, okay. Got it.
Who wants to take a shot at what this equation is?
Have we seen it before?
Say it again?
Have we seen it before?
No, all the pieces are here. All the numbers you would ever need are right before you. Start out with what's the maximum current?
Maximum is the 100, sorry, that's volts.
Remember, we use capital letters to represent maximum values.
Is this just a V equals IR situation, but we're putting the lowercase in?
The lowercase is our instantaneous value. So once we have this equation, if you know what the time is, we can pop that time in there and come up with what the values are. But whenever you're doing an equation, there's some amplitude. This is just the amplitude over our cosine curve. These are all amplitudes here, I'm just looking for the amplitude of my current.
Is current 2.828?
How'd you get that?
I just used Ohm's law to like, from our maximum voltage, I like divided it by resistance.
Yeah.
That was a shot in the dark.
Did you use, what maximum voltage did you use?
Our value over here, the 141.4 volts, and then divided it by 50.
You would pick that value right there. This is the maximum voltage across the resistor.
Oh,
And
yeah.
if you divide it by R, then you're talking about the resistor.
That is 1.39.
Well,
Yep.
Oh. Okay.
So 1.39 amperes times the cosine of 377, oh, sorry, I scrolled that for you. It's the same omega. Radians per second times time. And then what's my phase?
The phase shift.
Yep.
would it be 0? One of these things is overlapped with V sub C, and I can't figure out which one it is. I'm gonna guess it's this one and say it's 0.
Alright, look at the phasor diagram. My phasors for the current are in sync with, or in phase, properly worded, with which one? Which phasor is pointing in the exact same direction as my current phasors?
Voltage of the resistor.
Yeah, so what's the phase of the voltage for the resistor?
1.56.
You did say all the numbers were up there. Yeah.
Questions up to here. There are obviously some general questions, but we'll do another one. Why don't I just push this one through? If you've got a burning question, please ask it. So let me give time for that.
I don't even really know where to begin to ask a question, so I'm just gonna hope I can like absorb what this is.
All right.
Yeah. I hear you.
Well, of course, when you do the lab, it'll all become clear.
Oh, I'm sure.
Or will we be more confused, like usual?
All right. These formulas right here are telling us the formulas for my voltages and my currents at any moment in time, given the way we set up the problem. So what I want to do is after 1 second,